Hello everyone, welcome back to another Top Dog video. My name is Dylan, your favourite Year 6 Stats teacher. Definitely when compared to Hayden anyway. We are here back with another brand new video. Now as you've probably seen, Hayden's going through some arithmetic things with you. We're going to have loads in general. Okay, so today, what I thought we'd do is go through all of the perimeter type questions we've seen come up in the Stats previously and find out exactly how to tackle them. Now before I get started, why don't you hit subscribe and like and let us know in the comments if you found these videos useful and what you want to see from us in the future. However, I also want to talk about perimeter in general. What does perimeter mean? Well, peri means around and meter means to measure. You guessed it, it's when we measure around a shape. Now, these questions are going to be tricky ones. So if you're looking about what perimeter is in general, this might not be the video for you. But everyone out there who thinks, oh, I already know what perimeter is. I can add up the sides of a shape and get the total. Okay, when the Year 6 Stats, it gets pushed to the next level. We look at problem solving. So we're going to start off easy, and then we're going to get harder as we progress through. Let's take a look at the first question. In the top right, you can always see what year this question was from. This is from the 2012 Stats. Which shape has the longest perimeter? This is quite simply just testing to see, actually, if you're sat in the test, do you know what perimeter means? Do you not get muddled up with area, which is what we see a lot with these questions? The children who approach them say, oh yeah, I can do that. A has a perimeter of 1, 2, 3 hexagons. No. The space taken up by the shape is the area. We want the perimeter, so we want to measure around the shape. The first thing I'm going to show you, if you're measuring perimeter around the outside of a shape, the best thing to do when you're counting sides, which we are in this case, is to draw a little line when you've counted it. Therefore, you don't count them twice. So A has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. A has a perimeter of 14. Do we know what the unit is? No, but it doesn't matter because they're all the same. So 14 of whatever that is. We can call them centimeters, meters, millimeters, whatever we like. We're looking for the longest. So let's speed it up now. B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Again, it's not going to be A or B because they're the same. We want one that has the longest. Let's check C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Much better. It's not B, it's not A, it could be C. Let's keep going. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's not D. That's 16, that's less than 18. And the last one, E. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have a simple case here of C. The most basic version of a perimeter question, we simply just count around the edge. In this case, it's C and it's testing, do we know what perimeter is? I hope by now we do. Next one, this is from the 2013 paper, and it's testing here if we understand the link between perimeter, which we're talking about in this video obviously, but also our geometry. Do we know the features of a square? What makes a square a square? Well, this one's given for us. The side lengths here are 9, 9, 9, and 9. So we know every side's the same in a square. The total perimeter here is 36 centimeters. Now in this question, guys, what I want you to do, I want you to try and solve it yourself. And you might be thinking, all right, well, what is the question? Well, the total perimeter for every shape is 36 centimeters. So what you need to do is figure out what would the sides measure. Now you might be thinking, how? You can do it, I promise. The number one thing to think about is when you add up all the sides of this rectangle, it has to be 36. When you add up all the sides of the rhombus and the kite, also has to be 36 for each one. Have a go and think, what are the features of each shape? I'll show you how to answer it properly after. Okay, so let's look at the rectangle first. What do we know about a rectangle? Well, I might want to draw it just to make sure. And one of the features we're being tested here for a rectangle is that opposite sides are equal. So if one of them is 3, well, we know straight away the other one must be 3. So we can write down 3 centimeters straight away. This is where we have to use the perimeter to work backwards. The total is 36. So far, we've got a 3 and a 3, so that's 6 in total, which means the remaining 2 sides altogether must equal 30, because 30 plus 6 is 36. So what does each side equal? Well, we take 30 and we split it in half. That'd be 15 and 15. So that's how we can figure it out for a rectangle. The way you can check this, guys, quite simply is to add these up. 15 plus 15 is 30. 3 plus 3 is 6. We've got 36 in total, and we have 2 pairs of exactly the same length to make the rectangle. Well, what about a rhombus? Now, you might be thinking, gosh, I'm not sure about the features of a rhombus. And if that's true, you're going to find this quite tricky. However, you could still work it out. We've got a 9 here. Okay. Well, let's say the opposite side is also a 9. Cool. That leaves us with 18. What's half of 18? It's also 9. But the best way to answer this question, guys, without having to guess and think what a rhombus could be, is to learn the properties of a shape. A rhombus is very similar to a square. And one of the features of a rhombus is that all the sides have the same length. The only difference with a square is a rhombus does not have to have right angles inside of it. This could count as a rhombus here if all of the lengths around the outside were the same. Now, what about a kite? Again, if you know your properties of a kite, you're going to find this simpler. We have a 10 centimeter, and for a kite, we have two pairs the same length, but they're not opposite anymore. They actually touch each other. So the two lengths here are 10 centimeters and then another 10 centimeters. That gives us 20 in total. How many more do we need to make 36? That's going to be 16 split between two sides. So each side here is going to be 8 and 8 to make our kite. And we can actually fill this in. Now this question, just so you guys know and understand, in the year 6 SATs, the problem solving questions you're going to be given quite often will overlap different strands of math. So you won't just be counting sides. This question was nice because we literally were. But for this question, we're combining it with our knowledge of geometry. So you have to stick around for videos in the future about that. But they're the answers to that question. Well done if you managed to get that. Next one. This is, again, perimeter. But what we find in the SATs, guys, is with perimeter will overlap like we just talked about. This one is overlapping with algebra. Why don't you have a read yourself and try this one out without any of my help, and then I'll come through and help you after. Little hint here when you're taking the SATs paper is to look at the words in bold, especially. Circle all the methods. Now, if we see this straight away, I'm thinking, okay, there's going to be more than one, I think. It could just be one, but the way this is worded makes me think there's probably more than one answer. All the methods below that can be used to work out the perimeter of this rectangle. So firstly, let's take a look. We have 6 centimeters here. Cool. And we have a W. Now, what I'm going to do, before I even look at the algebra at the bottom, I'm going to label the other sides because we know opposite sides of a rectangle are equal, a key fact to understand in perimeter. So whatever W is, that side's W as well. And 6 at the bottom means that there's a 6 at the top. Cool. Now let's take a look at the algebra to see what works. W multiplied by 6. No. This is leading into what I spoke about in the first question, which is confusion with area. To work out the area of this rectangle, you would do 6 times whatever W is. That would give you the space in the middle, but not for the perimeter. So we're going to leave W times 6. I'm even going to cross it out. I don't like it. Next one, W times 2 plus 12. Let's test it out. We've got a W on this side and a W on that side. So that would count these two sides. So that works. W times 2 gets me these two. And then I've got a 6 and a 6 left. Well, guess what? 6 plus 6 is 12. So we do add on 12. Therefore, this is an equation that works. Are we going to stop there and move on? No, of course not. We're going to keep going. Let's look at this bottom one here. We're also, by the way, testing out our bid mass, the order of operations, because we should know that we have to do what's in the bracket first. Let's take a look at the bracket then. W plus 6. Okay. W plus 6 would get me this 6 plus this W. So that gets me that bracket there. And then I'm going to multiply that by 2. Aha. That does work. Can you see how 2 lots of 6 plus W will get me another 6 plus W, which gives me the rest of the sides? That does give me the perimeter. Am I going to stop there? No, because of the way this question was worded, all the methods, we need to try them all. Next one, 6, tick, plus W, tick, plus 6, tick, plus W, tick. The most basic way to work out perimeter. Most children would just put this one and move on. However, we proved that the other two work as well. You would need to put all 3 down to get the marks for this question. Be careful and watch out for when perimeter is muddled up with another strand like algebra in this case. Next question from the 2014 paper. I love these types of questions, guys. As perimeter questions get more and more into problem solving, I think it really stretches our brain because perimeter alone is quite simple. Let's take a look at this one. I'm going to read it to you. This shape is made up of 4 identical curves. Now, just so you know, the curves end where my blue lines are. Can you see those 4 curves? 1, 2, 3, and 4. They're identical, which is really important. I'd be underlining this. The perimeter of the shape is 28 centimeters. So if you've got your problem solving hat on straight away, you might already be thinking, I can work out each curve because they're the same, means I can divide to get equal groups. There are 4 sides. So straight away I'd be thinking, okay, 28 divided by 4 if I know my times table facts, which are really important, I already know that each curve is 7 centimeters. That's something I would be doing straight away. Okay, and I've jotted it down here, and I'll show you what I do later on as well. The rest of it's for you to figure out. A new shape has been made up out of curves the same size. What is the perimeter of this new shape? Show your method in this box. Have a go at jotting it down, or maybe you can try and do it in your head if you don't have paper. Whatever you do, try and get to an answer. Then I'll go through it with you afterwards. So this working out here, it's great that we're doing it as we go. If you've got your problem solving hat on, if you've done that, I would write it again in here just to make sure. We'll take the 28 and we're going to divide it by 4. That gives us each one of these curves is 7 centimeters. Write it in this box just to be sure, because you could get a mark if you show all of your working and make one small mistake. What is the perimeter of this new shape? Well, quite simply, it's going to be 7 multiplied by how many of the curves are used. We have 1, 2, 3, 4, 5, 6. Big reliance here on knowing our times table facts. 7 multiplied by 6 is 42. We put 42 in the box, and luckily for us, we're already given the units. Now we get 2 marks for this question. The only reason we'd get 1 mark is if we show our working out, but we've made a mistake somewhere. If you don't show your working out and you get it wrong, 0. It's always worth showing your working out. I love this question. No help from me for this one. This is Alfie's shape right here, and we're given this key on the right-hand side. Okay, so the width is 8, and the length is 3 of the rectangle. What is the perimeter of this shape? The only thing I'm going to say to you is perimeter is the outside of the shape, not the inside. That's it. That's all I'm going to do for now. See if you can get an answer. I'll go through it with you afterwards. Okay, so for this one, I'd be annotating all over this up here, and I'd be thinking, okay, the long length is 8 and the short is 3. So I know this length is 8. I know this length is 3. What on earth could this length be? Well, here's where we have to do our first bit of working out. 8 is the length of the entire rectangle, but we don't want the entire rectangle. We just want this bit. So we're going to have to take off this. Luckily for us, we know what that length is. It's 3, because the end of the rectangle is 3 centimeters long. Perfect. So I can do 8 take away 3, and I'm going to get, you guessed it, 5. I'm just going to write this down just to show my working out. Simple as that. So I know this is 5. Then this length here is a whole width of the rectangle, so that's an 8. Again, we've already worked out this is 5, this is 3, this is 8, this is 3, up until here. And then there until there, my 2 blue lines is another 8. And then this short distance here is a 3. We have to show our working out, so just add them up as you go. And this is vital now. Tick them off as you go, okay? So 8 plus 3 is 11. I'm going to cross them out. Plus 5 is 16. Okay, I'm going to jot it down as we go. I've still got plenty to go through. I've just done 8 plus 3 plus 5 is 16. I've got another 8 plus 3 plus 5 here. That's going to give me another 16. 16 plus 16 is 32. I'm going to add this 8 on because 2 goes nicely with 8. 32 plus 8 is 40. And now I've only got the bottom sides left. 3 plus 8 plus 3. Well, 3 plus 3 is 6. Plus 8 is 14. So I'm going to do 40 plus 14, and I get 54 centimeters. Be systematic. Cross them out as you go. Don't add up the same number twice. That is classic problem solving right there. Stick around to the end because you'll be able to have a go yourself. Next question. This is from the 2014 paper. Each side of the triangle is 10 centimeters. Each side of the pentagon is D centimeters. We don't know what D is just yet. However, let's look at the rest of the information. The perimeter of the pentagon is 4 centimeters more than the perimeter of the triangle. What number does D represent? So you need to figure out, well, we know each side of the triangle is 10. What is the perimeter of the triangle? The pentagon is 4 centimeters more. And then you've got to figure out the length of each side. Multiple steps to this. Have a go and see what you can get, and I'll show you how to do it after. So, step 1. We have 10 for each side of the triangle times 3. Why are we multiplying it by 3? Well, that's because a triangle has 3 sides. So the perimeter of the triangle is 30 centimeters. The pentagon is 4 centimeters more. So the perimeter of the pentagon is 30 plus 4, which is 34, of course. 34 centimeters. Fantastic. Now the perimeter of the Pentagon is 34 centimeters. What's the length of one side, which is D? Well, we're going to have to take 34 and we're going to divide it by 5. We can use the bus stop method here. Again, keep an eye on our videos. If you're not confident with bus stop in this scenario, and you'll see why in a minute, go and watch other videos on this. How many 5s are in 34? Well, how many 5s in 3? 0. Exchange over, and we get the same question. How many 5s in 34? So we have to know our times tables. You can count up. 5, 10, 15, 20, 25, 30. Not 35 though, that's too much. So just 30. There are 6 5s in 34 with 4 left over. We can't just leave that. We need the length. So we're going to have to keep going, put a decimal and a 0 placeholder. That 4 crosses over, and we put the decimal at the top as well. How many 5s in 40? 5, 10, 15, 20, 25, 30, 35, 40. That's 8. I always count my fingers just to make sure. 6.8 is the length. But what do you need to do? That's right. Use your units. 6.8 centimeters for the length of each side. Fantastic work, guys. Well done. Next, this question. This is possibly one of my favorite perimeter questions. I'm that kind of guy. I've got a favorite SATS perimeter question. This is from 2015. What is the perimeter of Chen's shape? This is Chen's shape, by the way. Now, what you need to know, some extra information, is those grey I won't give it away just yet, but those grey shapes, let's say, they have the same length sides. They are squares. That's going to be really important, okay? You might be looking at this thinking, what? If this came up in my SATS, I'd have no idea what to do. Well, you'd have a go first, right? Which you're going to do now, and I'll tell you exactly how to solve it after. Okay, I love this. I love this because we need to use this key up here. Okay, the long length of the triangle is 13. Then we have a 12 and a 5. So let's measure what we know. We know this long length here is 13 and 13 and 13 and 13. Okay, cool. But I've still got this side, this side, this side, and this side. How can I possibly know what the length of that side is? Well, you can, because look, the lengths of a square are the same. So it's also the same as this length, which is the length given in this triangle right here. This is our 5 side. So we can extrapolate over and say this is 5. We can say this is 5. We can therefore say this is 5. And we can say this is 5. Let's see. We've got 4 13s and 4 5s. So I'm going to do 5 times 4 is 20. And 13 times 4, I can do 12 times 4 is 48. Add another 4 is 52. Which means altogether, add these up, 20 plus 52, it's 72 centimeters in total. If you're ever in the situation, think, I can't possibly do it. Well, it wouldn't be a question if you couldn't. So try and think outside the box. Experiment. Look at what you're given, like this key here. We know it's a square, so the sides are the same. If you ever see a question where it says, these are squares, it's probably pushing you to think, what do you know about squares? And can you apply that to try and solve this problem? Fantastic if you gave that a go. Oh, these questions just keep coming. Guys, for this one, quite simply, I'm going to stay quiet. You're going to have a go, and I'll come back after and tell you how it's done. Try and solve this SATS question. I love these types of questions because, look, now we're starting to have area come in. And remember I talked earlier about how some children get mixed with area and perimeter? Well, the SATs push into that, and they often like to overlap area with perimeter in questions. The area of this square, what did I just say about squares? If the question says it's a square, it's probably wanting you to use that fact of what you know squares do. It's 36 centimeters. So something times something gives the area, which is 36 centimeters squared. Now for area, we multiply the width by the height. In this case, it's the same number. What number can we multiply by itself to get 36? Using your square numbers, which you might well have learned, it's 6 and 6. So we know each length of the side of the square is 6, 6, 6, 6. Cool. You could be doing this working out in the box, by the way, if you want to make sure you show your method, but you can also write up on the question. It's up to you. Okay, well, let's look at the actual question, shall we, before we get carried away. It is cut into 4 identical rectangles, which we can see here. So actually the cuts go imaginary about here, but it's identical. Okay, so that's good to know. What's the perimeter of one of the small rectangles? Okay, well, let's go and draw over here on this rectangle. Firstly, we know that this length is 6, which means the length across is also 6. So we've got those two sides. But what would the smaller sides be? Well, there's a way to work this out, which is quite simply, you know the whole length of this side was a 6 before it was cut. We're going to do 6 divided by 4. If you're thinking, what? How can I do that? If you're really stuck, just whack it into a bus stop and you'll see why. How many 4s in 6? Well, there's one group of 4 and there's 2 left over. That 2 needs to exchange over to a placeholder after the decimal. Put a 2 in, put a decimal at the top. How many 4s in 20? That's 5. Okay, so each side here is 1.5 centimeters. Once we've got all of that, we can use any of the methods we looked at earlier. We can just add them all up. We can double them, whatever we want to do. 1.5 times 2 is 3. 6 times 2 is 12. Add them together and we get 15 centimeters is the perimeter of the shape. Fantastic. One of the trick answers we would see here is if the perimeter, 6 plus 6 plus 6 plus 6 is 24, lots of people would just divide that by 4 and get 6 and say, oh yeah, it must be 6. No, we have extra lengths once we cut them. Be careful. Loved that question. Well done if you gave that a good go. This is the last one we're going to do together, but like I said, stick around because we've got another question after. You can have a go at yourself. Regular hexagon, square. Please, you've noticed something. It's telling you things that it wants to give you a hint for. A regular shape has the same length sides. A square has the same length sides. That's going to be key information to solve this. Do you know what? I'm going to read it because it's a very tricky question. I loved this question. It was my favorite question on the 2019 SATs. Let's take a look. These two shapes have the same perimeter. Key information, same perimeter. The length of each side of the hexagon is 8 centimeters. Guys, I would be drawing this right away. I would just be labeling it. Why not? Let's not try and store so much information in our head. It's just get it down on paper. Calculate the area of the square. We're doing it again. The actual question is asking for the area. Why is this in a perimeter video? Because it is based around understanding perimeter. Okay, that's why. Have a go at solving it. Can you get the area of the square if you're given the length of each side of a hexagon? You can. Give it a go. I'll tell you how to do it after. Okay. Hopefully you had a go there. Let's see. So these two shapes have the same perimeter. We're going to use that fact. Can I work out the perimeter of the hexagon? Yes. I'm going to take 8 multiplied by the 6 sides. 8 times 6 is 48 centimeters. That means that I know that the perimeter of the square is also 48 centimeters because they're the same. Now, once I've got that, I need to work out the length of the sides of the square to get to the area. Remember, the equation for area is base times height. So how do I do that? Well, it's quite simple. 48 divided by 4 equal sides. 48 divided by 4 is 12. So again, I'd be just writing this in as we go, showing the examiner I know exactly what I'm doing. What is the area of the square? Well, we do base times height. 12 across, 12 up. 12 times 12. So reliant on these times table facts. But if you know them, you're going to get all the marks here. What a fantastic question. What a fantastic problem solving question. Hopefully you gave it a good go. And if you didn't know how to do it, well, now you do. And as I promised you guys, I've got a question that I've written just for you. Very similar to the last one, but a different type of problem that requires you to think for yourself. And you'll see what I mean if you have a go at this. Guys, let us know in the comments, how did you find this video? What do you want to see in the future? Like it, subscribe to us, share it to anyone you think it would be useful for. I hope you enjoyed it, and I'll see you again next time. We've got loads more SATs videos on the way. Good luck.